Hello, welcome to the podcast explaining today's kind of the outcome of today's math meeting that we had. Looking at a picture here of Denise's board, where we listed out some things with our number patterns unit that we're in, and then also some function vocab, some things we need to cover in function. The talk was kind of how do we go from here to here. My plug is going to be that in between we need transformations. So that's geometry. I think we need to have that in between our number patterns, and then this will be a nice jump into functions. And also we can do some of our function things, concepts as we do transformations. Like, for instance, a parabola. When we are graphing number patterns, so we got the squaring pattern, right? The symmetric nature of a parabola, right, is just a reflection. So if we can talk about our transformations, we can make a lot more sense about not only shapes of graphs, but our input-outputs and how transformation just changes our outputs. Okay, so I'm going to talk about the number patterns and some Geogebra apps that I have to help us, I think, with this. And then I'm going to make another podcast talking about the transformation progression. So I kind of broke down what to cover, when to cover it, sort of thing, and then talk about the Geogebra apps and worksheets that I've made. I have most of the resources made for the transformation units when we get there, but I'll talk about that in another podcast. But keeping in mind in both podcasts that this is really trying to answer this question: how do we go from number patterns, graphing, what do we want our students to be able to do, and then how do we get to this function stuff here? Okay, so here, let me just talk about the Geogebra apps. I put in our Dropbox, remember, is the HS Math Department 1 at gmail.com, same password's the same thing. If you go to Dropbox, then let me sign out here. Put these deleted files, I don't really like that, but you sign in with that information. Okay, this is the Dropbox account that we have here. There's a lot of stuff going on right now. I've got to clean this up, but there's a new folder here called New Geogebra Apps for Number Patterns and Transformation. So if you click on that, I broke down some units here. So this podcast is going to go over the apps that are in these 6 apps right here. Well, actually, these are transforming functions. These will be in when we do function stuff, the transforming functions. But I do want to show these apps and just kind of explain also in this podcast how I, what I focus on in my lectures and whatnot, and how I would have students go about it. But it's just my own opinion. But anyways, if you go to that, you have all these apps that I'm showing you. Also, like reflections. These are my compiled worksheets, tests, and Geogebra apps that I've used for reflections, and I have the same for rotations and translations. As far as transformations go, I haven't done a whole lot of dilations, so we need to build that too. I think we should do dilations anyways, get all our transformations covered. So in the unit, I didn't title it with a number. I'm not sure how the number system works yet, where we're going to put what. But in this unit, number patterns and graphs, 3 of these are sequence generators that I've made here. So we have linear pattern with 2 points. When we start talking lines, why do we only need to know 2 points when we got the equation and we know what the graph looks like? So I'll talk about that app. Exponential and linear random pattern generator. So this is kind of neat. This will create a random first term random difference for linear. Well, I'll show you. And then arithmetic sequence creator. Let me just go. I made a podcast already. I haven't shown it to you. It's in the email with all the YouTube links about this app. This is kind of what we want to get to we have the 4 different kinds of functions: linear, quadratic, absolute value, exponential, and the podcast kind of goes over what this is for. So if you have any more questions on it, please feel free to ask. Okay, so that's going to be when we get to functions, though, transforming functions, I believe, and we start looking at equations. So what I would do first with the patterns, this one is the random pattern generator, exponential and linear random pattern generator. So you can click whether you want to do a linear or exponential. So if you click linear, okay, it says set first term value. I'm just calling it F if we want to make equations later. Set the difference between terms, the D for difference. Okay, and then I have 2 other checkboxes here: show input output pairs for linear and show input output table for linear. Same deal with exponential. It's just set first term and set your multiplier. But what we can do is, so I'm going to show my table. So I'm going to click the table. Okay, I got the first input output pair highlighted in red so that they can identify first term, and then I just have this app is going to graph these 7 input output. There's only 7 input output pairs in this app here. So you have the table. If you click show linear pairs, the input output pairs, you also see the graph. Okay, so we could do lots of stuff in our discussion. We'd have kids with the laptops or iPads for Jody. Have them mess around with this stuff. But this would be a good group discussion of looking at the difference, right? It's linear, so we know there's a common jump. Looking at your first pair and then plotting the points. So just going from table to graph. Okay, so if I click on set first term, it's just another random first term. Set difference. So we can talk about differences, increasing, and we got a table that goes with it. So good app to discuss the tables to graphs and graphs to tables. I don't have any worksheets made. I'm going to, but I can just see worksheets looking like this. Like, here's a table, right? Take a screenshot of this, have them plot, these points. So maybe like plot this one. So they need to have the 7 points on here, right? And change the scale. In Geogebra, by the way, when you change the scale of your axes, you need to have your Move Graphics view tool. And if you put it over the axis, it turns into arrows. And if you click and drag, you can change your scale of your axes. So like for my homework, I would maybe do this, because 23.5 is my largest. I could even stretch out, something like this. But 23.5 is my largest, and 25, so 30 is this output. So that'll give us enough room so they can graph 1, and 5.5 is just a little above, right? Not perfect, but they need to see that too. Same deal with exponential. If you click the exponential pattern generator, set first term, if stuff gets left shown, uncheck it before you uncheck the linear pattern. Okay, so what I mean by that is, like, if I have this and I don't want to do linear anymore, I want to do exponential, so I'm going to hide linear. The table and the graph still stay there, so you have to go back into the linear pattern generator and uncheck what we don't want shown, and then uncheck it. So we can go to exponential. So set the first term, set the multiplier, show the table. So now we have an exponential pattern. Okay, and then when we show the ordered pairs, we really need to, especially depending on our multiplier, this looks like a pretty decent multiplier here. Maybe I'll change it. Negative multipliers, so this is kind of interesting. So as we change our scale, they can see this graph is sporadic with the negative multiplier, right? But if we have a positive multiplier, like this one, right, we can see the exponential curve, and we can change our scale so we can put all our points in the screen and see that it's not linear. Okay, so yeah, anyways, this is just a random linear and exponential pattern generator app. Okay, go to the next one. Let's look at this one. Right now, this is just set up for linear sequences, arithmetic sequences. This app, I have the table here so you can see input output. I'm going to hide we don't need the algebra window. So you can set the number of terms in the sequence, right? We have all the sequence here, so when I change my sliders, notice the table and the spreadsheet values change, so everything changes dynamically. We can actually change the number of terms we want in the sequence. So if our first term, the way that this is set up, is saying that our first term is -4, so first term is -4. Right now the difference is 2.5. Maybe I want to change that to adding 5. So now, if we start at -4 and we add 5, then our second term should jump to this point. Right? We can see, rectangles here, which help us understand as we go over 1, we go up 5, over 1, up 5. So as we add points and we need to change our scale so we can see more, maybe we'll do this. And this is good too, when you change the scale around, it's good for kids to be able to see what scale really does, and how we can read it not always just being 1. These go up by 2. So as we add points, we can see what's happening here, and we can see a nice linear pattern going on here. Okay, so you can change your difference. If you want to make it negative, notice we have the line, the pattern going down. You can change your first term, which is kind of neat. It just translates the whole sequence, right? So as we talk about output values, all our outputs are just getting increased or decreased by the same number. And then our slope, we can change. So kind of neat. I like seeing the input-output lines, so they can it's easy for the eye to come over and see, what's what. So they can start seeing ordered pairs as input-outputs. So that's what kind of led me into this next app, which is the linear pattern with 2 points. So at some point when we want to use this talk about why do we get to write an equation based off 2 points, this is really kind of nice to see. You can move your 2 points around by either clicking in the box here and putting the ordered pair values. So if you want to make a worksheet for the kids to work on, tell them to set your pairs and then explain the pattern and whatnot. Or they can just click on the point and drag. Sometimes in Geogebra, when things don't work, you just have to kind of click in the white here, which unchecks everything, and then try it again. But you can move your points around, which is cool because it shows the ordered pairs. What I like about this is, how do we get from A to B, right? So I have 3 check boxes here. That to have that talk, how to get, from A to B here, I'm going to show directions between points with vectors. So it's actually showing an increase of, and we got to read our scale here. This is going up by 1, so going by 1s we're okay. An increase of 1. So if we go up 1 and then over, it looks like from -1 to 5 we go over 6. So it looks like our slope's going to be 1/6. Also going from B to A, we can go down 1, we can go left 6. But the red, the diagonal, notice we have a nice rectangle made here. Whenever we do this, we're going to get rectangles, right? So a good connection to geometry. Now this one looks like it has a slope of up 2, and then we go over 7. I'm going to make it nice for this example. Up to over 6, so a third. Now what we can do too is we can do a couple things here. I'm going to take a screenshot of this real quick. Oops. Hold on a sec. Sorry, something happened. Okay. I'm going to take a screenshot, because this is something that I think we can do too. Once we can understand like slope, we can also use these coordinates to help understand slope concept, because what we can do, I'm going to put this into Smart here. What? Sorry, something didn't happen there. Copy to clipboard. Well, sorry about that. I'll use the right tool here. My bad. So what I want us to understand is, if we put in a -2, we get out a 1. So if we think about sequences, the thing about sequences in equations, sequences only focus on the domain of our positive counting numbers, like 1, 2, 3, 4, 5. But we can extend pattern reasoning and extend our domain. So think about this as the -2 term, right? We know that we got out of 1. The -1 term we don't know. 0 term we don't know, right? And I'm just getting them from our x value. The first term we don't know, second term, third term, but we do know that the fourth term we get out 3. So now we can see a sequence here. How many numbers, what's our same number that we're adding to go from term to term, so we can get out of 1 in our -2 term, and we get out of 3 in our fourth term. So really, if these are the same jump, we should get the kids to understand slope being, we're going to take the difference of our outputs and divide it by the difference of our inputs, right, which is our slope equation. So then we know that we get 2 over 6, which reduces to, there's our up 2 and over 6, right, which reduces to a third. So that's one thing that I really like, connecting this concept to our linear sequences, talking about now, what if I have the -5th term and say, the first term? If I know those two outputs or terms in the sequence, I can figure out the rest, right? So I wanted to show that too. Delete my pen stroke there. I wanted to show that too by saying we have points in between. So now it's showing in between, like our -5th term, if that's what we want to call it, and our first term. We can see our -4th, -3rd, -2, -1st term, 0 term, and so forth. One thing I thought was interesting is I wanted to have kids understand that this is dense, meaning there's an infinite amount of numbers between, or points that fit this linear pattern. So we don't always have to go up by 1, so another jump from sequences now. We can change an x, we can change what these points jump by with the slider. So 1 is the biggest jump I made, but we can also make less. So now our jump maybe is going to be a quarter. So now this is -5, this would be -4 3/4, -4.5, -4 1/4, -4, right? Jumping by quarters now. But when we make our difference really, really small, we can see that there's a ton of points in there, right? So that can help us understand, I think, the density. So input-output concepts would be, what if we had the -4.25 term? We can still figure out the output because it fits our linear pattern. Also, I wanted the students to extend our number pattern. So when you click the third box here, show points that extend patterns, now we can see the patterns continuing on outside of our data. So I want kids to understand that they can extend lines and whatnot based off of what we know. And again, if we change our change of x, notice now the whole line here, these are a bunch of points. The difference between 5 100ths in our inputs creates this nice dense line. So helping kids understand what graphs and patterns are, right? So now as I change my points around, you can see the line moving, right? So we only need 2 points to really define a line, okay? But the concept is just, it's slope, but we need to move from sequences so that we can start understanding function, which is inputs of all real numbers. Somewhere in here lives the square root of 5, and if we put that into our pattern, we should expect to get an output out. Okay, domain and range. Alright, so that's that, and that. So those are the 3 apps that I have, kind of working on linear patterns, exponential patterns, and building some function concept here with the linear pattern with 2 points app. Is kind of neat. Alright, so that's kind of where I'm going with what we're talking about with number patterns. Okay, being able to go from table to graph, table to rule, rule to graph, and graph to rule. So being able to translate, I think these apps are going to do a lot for, especially when we're creating equations. How do we explain what's happening when we change our first term We can use the numbers to kind of predict. We can go up to the 16th, but you can change this if you want. You can make your maximum number of terms be whatever. If you just right click the slider, go down to object properties, you can change your max to 2000 if you want. Okay, but anyways, kids can start connecting patterns that they see in a table to graphing to writing the rule, which is just describing what's happening here. Okay, so that's all for this podcast. I'm going to make the transformation one now.